Now just to review, I'm going to give us our steps again. Our first step is going to be to multiply one equation by a constant so that one variable has coefficients that have a sum or difference of 0. Then we're going to take the sum or difference of those two equations, which will result in eliminating one of the variables. Then we'll solve for the remaining variable, and then solve for the eliminated variable by using either equation that we have. Now sometimes we have a situation where we can't multiply just one equation by the constant so that we have variables with good coefficients. Sometimes what we have to do is actually multiply both equations by a constant. So we'll have to look at our systems to see whether we have to multiply one equation or both equations. And the example I want to show you will give us an example of having to multiply both equations by a constant. Here we have 5x minus 3y is equal to 9. And negative 3x plus 4y is equal to 10. Now, we see that by multiplying either one of these equations separately by a constant will not result in us getting a variable with coefficients that add or subtract to 0, which means we're going to have to multiply both equations by separate constants. So let's take the x variable. Let's say we want to eliminate the x variable. Now we see the following. We see that if we multiply this top one by 3 and this bottom equation by 5, that both of these will be 15, positive 15 and negative 15. And when we add that together, we'll be able to eliminate the x variable because our coefficients will add to 0. So I'm going to go ahead and do that. I'm going to multiply our top equation by 3. So that's 3 times the equation 5x minus 30y is equal to 9. And I'm going to go ahead and multiply our bottom equation by 5. And we see that that results in the following. 5 times a negative 3x plus 4y is equal to 10. Now I want you to go ahead and multiply these through and then do the elimination. So you're going to multiply these equations by these constants to get a new system. And then I want you to take that system and perform the elimination and find out what the y equals. Okay? Go ahead and do that, and then we'll come back and we'll talk more about it. Welcome back. Let's see what you got. So here, we're going to get the following. 15x minus 9y is equal to 27. And here we're going to get a negative 15x plus 20y is equal to 50. Now, what are we going to do? We're going to take this new system that we have. There it is. I'm going to bring it right down here. And then I'm going to go ahead and eliminate 15 that we're going to add here because 15 plus a negative 15 is 0. Negative 9y plus 20y is going to result in 11y, and 27 plus 50 gives us 77, which leaves us with 0 plus 11y is equal to 77, or simply 11y is equal to 77. Then I'll go ahead and divide each side by 11, giving us a y value of 7. And now all I have to do is take any one of these equations and plug our y in to find out our x. Let's go ahead and use the first one. So, in order to find x, I'm going to say the following. 5x minus 3 times our y, which is 7, is equal to 9. So here we have 5x minus 21 is equal to 9. Going ahead and adding 21 to each side, I'm going to get that 5x is equal to 30. And then if I divide each side by 5, I get my final answer of x equaling 6, which gives us a solution of x is 6, y is 7. And we can go ahead and plug this solution into our bottom equation to check. Just to review, we have a system here that can't be multiplied, where we can't just multiply one equation by a constant, but we had to multiply both equations by separate constants in order to get a variable that can be eliminated. And then we went ahead and eliminated it, and then found our y and then our x. Good job. I hope you continue to work hard when you're working on problems where you're solving systems using elimination.